In this video, we're going to discuss briefly here how to find the equation of a circle. Okay, and when discussing circles, kind of unique equations. So I'm going to go ahead and bring this one up again. I brought this up in previous videos, but we say the equation of a circle in general is typically given by this right here. So it's really kind of hard to miss a circle sometimes, because what you'll notice automatically is that you got an x quantity squared, but also a y quantity squared, and they're summed together and they're equal to some r squared. And really, if you're looking at this kind of with a broad mind here, you'll notice that this looks very, very Pythagorean, okay? But we say this is the equation of a circle in standard form, where h and k, okay, both those, they represent where the center of the circle is. We say, okay, so the focus of the circle, and r is the radius, okay? So this is like our radius, not r squared, but r is the radius, okay? So let's go ahead and take a look at this example that I've listed here. But I say, oh, hey, you know what? What if the point 3,4 were to lie on a circle, and it had a center at -1, 2? Okay, so first things first, I think the most important thing is, and people tend not to do this, but is to sketch a diagram of the situation. Okay, so sketching this, let's go ahead and start with this. We say 3, 4. 1, 2, 3. 1, 2, 3, 4. Okay. So this is our point on the exterior of the circle. We'll make it pink, and then we say, okay, so -1, +2. And this would represent the center of the circle, okay? So what we do is we've got this circle here of radius r. This is our focus, and it proceeds around this, and I'm trying hard to draw this in, but here's the thing about it. In order to write the equation of the circle, we need to know essentially 3 things. We want to know what is h, what is k, and what is r. We're going to leave x and y alone. Okay. So to find the equation of this, we say x minus some h value. Sorry. I'm going to erase that there. Some h value. Whoops. Some h value squared plus y minus some k value squared is equal to some r value squared. Okay. So the neat thing about this is we already kind of have some insight into the center of the circle, hk. Okay, and so we said h. In this instance, we say the center was at -1, 2. So we say h is -1. Let's go ahead and go back down here and put in a -1. And for k, okay, we'll put in a +2. The only thing that happens to be a mystery here is this distance, okay, this distance r, right? Booyah, right there. So we're going to have to find that here in a minute, but I want to point something out real quick here. You'll notice over here that if I were to rewrite this already, you notice that we have x minus a -1, or in other words, flip it back to +1, that'd be squared, plus now y minus a +2. And when you take away positives, really, you can just leave that as y minus. So y minus 2 squared, and this is equal to r squared. But the important thing here is this. The center was at -1, +2, but you'll notice that in the equation it says +1 and -2. But that's the way it should be, so don't sweat it. So in order to find this distance r, okay, so you know what, this is not going to be such a problem, and that's r squared, by the way. Sorry. But to find this distance r, just recall that all we need to do really is use the distance formula, okay? And so for my peeps that need to be dynamic and see it and visual, we say this is all we're doing. We're kind of taking this Pythagorean approach to it, because this can form a right triangle. But we know these two distances right here. We say this delta y is changing y, and this delta x is changing x. But to use the formula, we say, okay, so the distance between 2 points, remember, was radical. We have these 2 squared quantities, but the difference in the y value squared plus the distance in the x value squared. So we say, okay, so let's take a look at these. Start with these, say the x values. We say, okay, so x2 minus x1, that would be 3. 3 minus a -1. Okay, it's the difference between our x values. And then we say the difference between our y values would be 4 minus 2. So 4 minus 2. And so what we're going to end up yielding is this. Distance here is 3 minus a -1, that'd be plus a +1. We've got 4 squared, or 16, plus 4 minus 2, which is 2, and 2 squared is 4. We end up with this distance, we say radical 20. Okay. So here's what I want you to notice. We say this is our distance d. In this instance, though, we're calling it r. Okay, so r is radical 20. That's our radius here. That's that distance we were looking for. Now, in another life, we might say, okay, so radical 20, my math teacher says I'm supposed to call this radical 4 times 5, and that radical 4 is actually 2, and put that out front, this is 2 radical 5. But in this instance, 2 radical 5. In this instance, what I can tell you is this. It's kind of groovy. You can tell me 2 radical 5, and it's still going to work, but let's go ahead and leave it as radical 20, because what we're going to do is we're going to go back and put it in here for r. So check this out. We end up with this, x plus 1 squared plus y minus 2 squared, and of course we got that h and k from our center or focus of the circle. But this is equal to r squared. In this case, we say r is radical 20. Well, hey, what happens when you square a square root? It actually eliminates it. So finally, we have the equation of the circle being x plus 1 quantity squared plus y minus 2 quantity squared is equal to just 20. And of course, if we were to say be given this equation in the first place and said, hey, graph this, what you can notice already right now is that h is a negative 1 and k is a positive 2, even though it says otherwise, okay? So we've got the center of the circle up here at a negative 1, positive 2. We say, well, if this represents r squared, the radius squared, then what's the radius? So the radius would essentially be the square root of r squared, and that'd be the square root of 20, which is what we just solved for right there. So this is just a nice example of how to find the equation of a circle if you know a point on its locus of points or on the outside of the circle and its center. So use it wisely.